This is the continuation of section 1.3. Okay, so section 1.3. And the name of the section is continuity. Continuity. And behavior. And limits. And in this section, first of all, I'm going to go ahead and do like a review of what I did on Monday, okay, just in case you forgot about the stuff about Monday. On Monday, I went over 4 scenarios, 4 cases of finding in continuity, if it's continuous or discontinuous. So the first one that I can give you is example number 1. If the function is f of x equals to 3x squared plus 4x and then plus 5. I'm just giving you a problem randomly, okay? So when you graph this, you're going to graph it. So get the calculator. Go ahead and graph it. So get your calculator, please. So instead of the 5, we're going to go ahead and put a minus 5. So let me put that. That's going to be minus 5. I'm changing the problem just so that it looks a little different. So when you graph that on your calculator, you're going to have the graph of a parabola. And then it's going up. Okay, over here it's 5. So that's the function. And if I ask you, what is, because it says determine whether the function is continuous at the given x value. And I'm going to say here at x equals -2. Okay, what happens at x equals -2? Well, the test for this continuity consists of 3 steps, okay? Number 1, first find the value. So step 1 or A, I need to find f of -2. So I put that into the equation. For every x, I put -2. Then I simplify that, so you can put that into the calculator if you want to. I'm going to do it, over here. So I'm going to hold on, stop it, and then continue. So when you plug in the numbers and you simplify the answer, that would be -1. Okay? Then step 2. From the test, part B, it says find the behavior, and on the textbook it's asking you to analyze the behavior by using a table, okay? So what we're going to do is we're going to analyze it by using the behavior of the function, like with using limits at x equals to the number that they're asking for, which is going to be -2, and coming from both perspectives. The right, so it's a plus. So I need to know what happens as I come to the -2 from the right, and also the limit of the function at x approaches -2, and then a minus, meaning from the left. Okay? So if you can see on the graph, if I'm approaching the -2, where's the -2? -2 is somewhere over here. Okay, so as I'm approaching the -2 from the left, so that means that I come this way. From the left, I'm going to be approaching a certain number. What is that number? Well, if you look at the graph, what number am I approaching? Look at your graph. -1, right? If you look at the graph, as you move from the left, well, in that case, from the left would be this one here, okay? This one, because there's a minus here. So I'm coming from the left. What is that number approaching? -1.
Wait,
so that's going to...
-1?
Yes.
Oh, it's because I don't know what's wrong with mine.
Calculator. Notice that at f is equals to -2, or the graph, that graph is approaching the -1, okay? -2 is -1. So I'm going to put here -1. What about if I approach that -2 from the right? It's the same. So if you have Third step, analyze the three pieces. If you have the three pieces, let me see, this is -1, this is -1, and this is -1. If the three are the same, then conclusion is continuous. F of x is continuous at x equals -2. -2. The answer was -1, but it's -2. And that's the last part. The three dots means therefore.
How do you know when you're coming from the right or left? Is it plus or minus?
Because of the plus and the minus. That is
When
right.
it's plus, what are you doing? Coming from the right?
Coming from the right. So when it's a plus, I read the graph coming from the right towards the -2. And that would be -1.
And how do you know it's continuous?
It's continuous when you have the A part and the two pieces from the B to be the same number.
Oh, okay.
That would be continuous. That means that it keeps on going and it's the same thing. Okay, that's number one. Second scenario. The second scenario, problem number 2. Okay, when you have the problem like on the worksheet that it says f of x equals, and then you have a piecewise function that was 2x plus 1 if x is greater than 2, and then x minus 1 if x is less than or equal to 2. And they want you to analyze this at x equals 2. So let's go with the three parts, okay? A, let's find f at that number. So I need to use only one of the two equations, right? Because it's 2, which is going to be the one on the bottom. 2 minus 1, which is 1. Okay? And the graph for something like this, let me sketch my graph. See here, for the first part, which is this part right here, I started 1, that's a y-intercept, and then I moved 2 up, 1 to the right, 2 up, 1 to the right. And I start at 2. So let me just graph that, and then I'm going to erase the rest of the graph. So at 1, I start here, and then 2 up, 1 to the right, 2 up, 1 to the right. So I keep on going. So from 2 and up, so that means that this is open circle, and it keeps on going that way. Okay, so I'm going to erase these points right here. Now, the second part. When I look at the second equation, which is this one, I start at -1, and then I move 1 up, 1 to the right, 1 up, 1 to the right. So I start at -1, 1 up, 1 to the right, 1 up, 1 to the right, and I continue, or 1 down, 1 to the left, and I continue. And x is less than 2 and equal, so that means that it's closed circle, and it keeps on going this direction. Okay? So now, part A, I got my value. Part B, let's study the behavior. The limit of f of x at x approaches the 2 from the right, and C, well, that's part of the A also. The behavior is just part of the A. So is the limit of f of x at x approaches 2 from the left. So as you look at the graph, if I come from the right, that is approaching what number on the y-axis? And that's going to be like, in my graph it seems like it's 4, right? But I think it's 5, right? Because it's 2 times 2 is 4 plus 1 is 5. I think I'm just missing one little line here. So that should be 5. So the graph approaches the 5. Now, what about if I'm coming from the left? So I'm coming from the left. That's approaching what y value?
2.
The 2. Okay. So since in my graph this was a 1 here, I think it's a 1. Are they coming through here? Why? Let's go. False alarm. They're not coming through here. So as I'm reading the graph from the left, that is approaching, like I said, you remember that I added a line here? That was supposed to be the first one here. So it's 1, isn't it?
Yes.
right? So it's 1. So that's going to be equal to 1. So this is the key to the piecewise functions. If your y value at the function to the number, it's equals to one of these two, or it's equals to a number. This is not undefined. If this is not undefined, it's actually a value, and the behavior jumps from one y value to the other, then it's jump discontinuity. Okay, these two are different. It's jumping, it's not the same as the last example. So this is jump discontinuity. Okay, so therefore 3 dots. Okay, there is a jump. What kind of sounds so? Sounds like it's out here. Jump discontinuity. Discontinuity. Oh my goodness. At x equals, what was the value? 2. So it's jump discontinuity. Okay, discontinuity. Third scenario. So limit of f of x, the translation to that is what is happening to the y as you are moving towards that number 2 from, and since this is a plus, from the right. Okay, so what is happening to the
Wait,
y?
Miss, you don't have it.
I don't. Don't laugh. It's okay. You don't know what we're talking about over here. Okay, my explanation again. So the limit of f of x means what is the y value? Is a moving towards the 2, okay, from the right. What's the y value? 5. What is the y value? The limit is just the behavior. What is happening, as you move from the left, because it's negative, from the left towards the 2, the y value, and here, like I said, remember that I put another line? So that's supposed to be 1. So what is the y value? The y value is 1. And that's it. Okay? That's the second scenario. Third scenario.